Yeah, good evening, children. Good evening. Am I audible?
Good evening, ma'am. Good evening, ma'am.
Good evening. Good evening. What's the progress, children? How much have you completed? First one?
Yes, ma'am. Yes, ma'am.
First one is over. Okay, fine. I'll not wait for you to complete the others. Let's get started. So we finished congruency in triangles from NCRT, and then I just gave you people a break because some of us were not really clear or sure about the the congruence conditions and other stuffs in this chapter. So I just gave you a break so that you can go through the recordings and be ready for the extra proofs. So I was supposed to start on Saturday. I didn't. So Tuesday, I think you have good time to go through the recordings. Fine. So this is the first one in the extra proofs. In the given figure, yeah. In the given figure, you can see the figure here. In the given figure, triangle PQR is an equilateral triangle. So PQR is an equilateral triangle on a side QR of a square QRST. So QRST is a square. You can see it below. QRST is a square. And on the side QR, QRST is a square. Okay. On the side QR, there stands an equilateral triangle. QRST. This quadrilateral is a square. So that means all the sides are equal. On one of the sides, QR of the square, there stands an equilateral triangle. So PQR is an equilateral triangle. Now, supposing the side of the square, each side of the square is 6 centimeter. So 6 centimeter, 6 centimeter, 6 centimeter, 6 centimeter, because it's a square, all sides are equal. Now this PQR equilateral triangle stands on QR and it's equilateral. That means all the sides are equal. You can see that QR is a side common to the square and the triangle. QR is a side common to the square and the equilateral triangle. So if QR is 6 centimeters, PQ and PR also must be 6 centimeters because PQR is an equilateral triangle. One side is 6 centimeters. That is the side of the square, but it's also the side of the equilateral triangle PQR. So QR is the side common to the square and the equilateral triangle. So you see that all these line segments measure 6 centimeters. That means the sides of the equilateral triangle and the sides of the square have the same length because one side is common to both the triangle and the square. Is that clear, children?
Yes, ma'am.
All right. Now that's about the figure. Now what should you prove? You should prove that triangle PQT is congruent to PRS. PQT. So you can see it here. PQT. This one. PQT. This one. This triangle PQT is congruent to triangle PRS. PRS. This triangle is congruent to PRS. So we need to show that these two triangles are congruent to each other. All right. Now we already know that all the sides of the equilateral triangle and the square are equal. We already know that. Now look at the two triangles in triangle PQT and PRS. Correct? We need to prove that this triangle is congruent to this triangle. So let's take up the two triangles. In triangle PQT and PRS. Now PQ of this triangle is equal to P. Okay. So in triangle PQT and PRS, in these two triangles, PQ of this triangle is equal to PR of the other triangle because they are the sides of the equilateral triangle. So they are equal. And then QT of this first triangle is equal to RS of the second triangle. RS of the second triangle again because they are the sides of the square. QT and RS are the sides of the square and all the sides are equal. Okay. And then this angle is equal to this angle. These two angles are equal because it's an equilateral triangle. So this one is 60 degrees And this is a corner of a square. So this is 90. So this angle, though it is not given, we can compute. It's 90 plus 60, 150 degrees. Because this part is 60 degrees. Equilateral triangle, this is 60 degrees. And this one is 90. This one is 90. Every corner in a square is a right angle. This is 90. So this angle and this angle is equal to 90 plus 60, 150 degrees. So this angle of the first triangle is equal to this angle of the second triangle. That is angle PQT. Angle PQT is equal to angle PRS is equal to angle PRS. PQT is a angle is an angle of the first triangle. PRS is an angle of the second triangle, and both of them measure 150 degrees. Both of them measure 150 degrees. Correct? So what is a congruence rule? What is a congruence rule? SAS. By SAS congruence criterion, the two triangles are congruent to each other. Two sides in the included angle. Two sides in the included angle. Okay, SAS congruence criterion, the two triangles are congruent to each other. All right. Now we also, the question is not complete. You have to also prove that actually I didn't tell you this. The question and the to prove does not match. 1 minute. In the question, it is show that triangle PQT is congruent to PRS. Okay, I explained that to you. That's how you prove that the two triangles are congruent to each other. But actually, it is proved that PT is equal to PS. The question is this. I'll correct the question and resend it to you. You can just alter the question. The question is to prove that the given information is correct, but we'll have to prove that PT is equal to PS and also angle PSR is equal to 15 degrees. This is what we'll have to prove, not this one, not show that this one. It's not this. It is given this information, you'll have to show that you'll have to prove that PT is equal to PS and angle PSR is equal to 15 degrees. So fine. Anyways, this is what we have to do. We'll have to show that these two triangles are congruent to each other. PQT is congruent to PRS. Now PT is equal to PS, CPCT. Because PT is equal to PS, CPCT. PT is the side of the first triangle. PS is the corresponding side of the second triangle. So PT is equal to PS, CPCT. And now we'll have to prove, the next thing is you'll have to prove that PSR is equal to 15 degrees. PSR is equal to 15 degrees. Okay. PSR, which is PSR? PSR, this angle is 15 degrees. This angle. So now let's take up this triangle. Look at this triangle PRS. Look at this triangle PRS. Okay. Look at this triangle PRS. Now you know that this side is equal to this side. PRS is an isosceles triangle because we understood now when we started the proof, meaning before starting to understand the proof, we just took each side of the square to be 6 centimeters and we understood that the side of the equilateral triangle will also be 6 centimeter. So you can see that PRS is an isosceles triangle. Not PS children. This one I have marked 6 centimeter. This is 6 centimeter. So you can see that PR is equal to PS. So clearly PRS is an isosceles triangle. PRS is an isosceles triangle. So if it's an isosceles triangle, these two sides are equal. That means the angles opposite to the equal sides are also equal. So this angle is equal to this angle. This angle, these two angles are equal. That is, see the two sides, they meet like this here. Leave the angle. The remaining two angles will be equal. See, this is one equal side. This is the other equal side. These two sides are equal. The two sides, they form an angle here. The two sides are the arms of this angle. The two sides are the arms of this angle. Leave that angle. The remaining two angles. So leave this angle. The remaining two angles. This angle is equal to this angle. Now you know that this is 150 degrees. This angle is 150 degrees. And so what is the remaining sum? 180 minus 150, 30 degrees is the remaining sum. So each angle will be 15 degrees because they equal. Because they equal, each angle will be 15 degrees. Understood, children?
Yes, sir. Yes, ma'am.
Yeah, please write this. Show that PT is equal to PS, and please correct the question, and angle PSR is equal to 15 degrees. Show that PT is equal to PS and angle PSR is equal to 15 degrees. Please go through the proof, children. Okay, let me read it for you. Let me do it again for you. So see here, children. First, take up the triangle in PQT and PRS. Because now the question is, why should we take up these two triangles? Because we'll have to show that PT is equal to PS. PT is a side of triangle PQT. And PS is a side of triangle PRS. So we have to take up these two triangles. In these two triangles, PQ of this triangle is equal to PR of this triangle because triangle PQR is equilateral. Then angle 1 is equal to angle 2, 60 degrees, equilateral triangle. Angle 3 is equal to angle 4 is equal to 90 degrees. Now add these two results. Add these two results. So angle 1 plus angle 3, see, add these two results. Angle 1 plus angle 3 is equal to angle 2 plus angle 4 is equal to 60 plus 90, 150 degrees. Angle 1, add the results, children. Angle 1 plus angle 3 is equal to angle 2 plus angle 4 is equal to 60 plus 90, 150 degrees. So what is angle 1 plus angle 3? PQT. Angle PQT is nothing but, second. Yeah, angle PQT is nothing but 150 degrees. 1 plus 3 is nothing but PQT. And 2 plus 4 is nothing but PRS. So these two angles are equal to 150 degrees. So that's the second point. Third, QT of this triangle is equal to RS of this triangle. Because QRST is a square. So the two triangles are congruent. PQT is congruent to PRS by the SAS congruence rule. CPCT, PT is equal to PS. PT is equal to PS. You should know how to write the order correctly. This order is important. PT is equal, PQT is congruent to PRS, so CPCT, PT is equal to PS. So we proved the first result. Sorry. So next thing is we'll have to prove that. The next thing we'll have to prove that angle 5 is equal to angle 6. That's the next job. Because you'll have to find the measure of angle PSR. You'll have to find the measure of angle 6. You'll have to find the measure of this angle. So see here, QR is equal to P. Now, since QR is a common side, to the square and the triangle, you take QR. So say QR now, which is the angle we have to find? Angle 6. Angle 6, because you'll have to show that PSR is 15 degrees. PSR is 15 degrees. We'll have to show that PSR is 15 degrees. Where is PSR? Angle PSR. Angle PSR is in triangle PSR or triangle PRS. Okay, so this is angle PSR. So we'll have to prove that this angle is 15 degrees. So we're trying to show that this triangle PRS, the triangle PRS is isosceles. Isosceles. Take up the side QR, which is common to the square and the triangle. Now, just say that QR is equal to one side of the square and QR is equal to one side of the triangle. See, it's very easy. QR, see, we have to take up this triangle. QR is equal to RS. QR is the common side. Now QR is like for the triangle and the square. So take up the common side QR. Now QR is equal to RS. Why QR is equal to RS? Because I said with QR you take one side of the square and one side of the triangle. Now with QR we have taken RS. QR is, see, we have to take this side and this side with QR. We'll have to, with QR, you know, see, it's very easy. Please look at the way I write it. With QR, you take PR and RS because you'll have to show that those two sides are equal. They are equal. You already put the numbers and understood. No, everywhere we got 6. They are equal, you know, but how to present that? How to present that? So take up this common side QR. Okay, now write one side of the square. One side meaning you should write this one only because that's only in this triangle. So is equal to RS. Then write QR is equal to PR, the side of the triangle, PR. That is true. QR is QR is equal to PR because, sorry children, I have a back to it. One second. Yeah, children. So why is QR equal to RS? What are QR and RS? QR and RS, they're the sides of the square. So they're equal. What about QR and PR? QR and PR, they're the sides of the equilateral triangle. So they're equal. So QR is equal to RS, QR is equal to PR. So from these two, we get RS is equal to PR. From these two, we get RS is equal to PR. RS is equal to PR. If RS is equal to PR, if RS is equal to PR in triangle PRS, then angle 5 is equal to angle 6 by the theorem that angles opposite to equal sides are equal. Now you prove that angle 5 is equal to angle 6. Now use the angle sum property. Use the angle sum property. So 6 plus 6, because 5 and 6 are they equal. So instead of 5, you say 6. 6 plus 6 is 150. 6 plus 6 plus 150 is equal to 180. Sorry. Twice of angle 6 is equal to 30 degrees. Angle 6 is 15 degrees. That means angle PSR is equal to 15 degrees. Is it fine, children?
Yes, ma'am.
Yeah, did you correct the question, all of you? Show that PT is equal to PS and angle PSR is equal to 15 degrees. This is the question. All right, let's go to the next one. Okay. So in the given figure, so in the given figure, ABC is a triangle. Can you see? ABC is a triangle, right angled at B. It's right angled at B. Okay, ABC is a triangle, right angled at B. So ABC is a right angled triangle. If BCDE is a square on side BC, so on the side BC, see here, this is the triangle. This is the triangle. This is the right triangle ABC, ABC. On the side BC, we have a square. On the square side BC. So on the side BC, we have a square. What is the square called? BCDE. BCDE. And ACFD is a square on AC. AC is the hypotenuse. AC is the hypotenuse. So we have a square on the hypotenuse. FG. So see a square on the hypotenuse. ACFG. FG is a square on the hypotenuse. Sorry, children, I didn't excuse myself. I just went away like that. Yeah. Yeah. So I was telling you that there is a right triangle ABC, right angle at B, a square BCDE on the side BC, a square ACFG on the hypotenuse AC. Given this, we need to show that AD is equal to FB. Where is AD? AD. You'll have to join. It's not there. You'll have to join AD. Should show that AD is equal to FB. FB. Okay, this is what you'll have to prove. Understood the question, children? Do you understand the information given?
Yes, ma'am.
Yeah. So we have a right triangle ABC, right angle at B. On the side BC, we have a square BCDE. And on the hypotenuse AC, we have a square again, ACFG. Now tell me, will the sides of the two squares be equal? Will the sides of the two squares be equal? Both of them are squares, no? So will their sides be equal? Both of them are squares. Will their sides be equal? Yeah. Are you there? Raja, Srijana, Krishmika. Class, use the emoji. Raise your hand. Sindhu, Sanjay, Krishmika, Shri, Raja. Srijana, are you there? Response. Yeah, children, my question, please answer. Will the sides of the two squares be equal? Or we can't say. Yeah, that also can be an answer. We can't say.
No, we can't say, ma'am.
We can't say. Okay. Okay. So let me say something. Now we know that the hypotenuse is the longest side in a right triangle. We know that the hypotenuse is the longest side in a right triangle. So we have two squares on AC and BC. Which is greater, AC or BC? Which side is greater? Which side is greater? Which side of the triangle is greater, AC or BC?
AC, ma'am.
AC, because it's the hypotenuse, correct?
Yes, ma'am.
Now tell me, which square is bigger? Which square is bigger?
Now square ACFG, ma'am.
The square ACFG is bigger because it stands on the hypotenuse. And we know that when we compare the sides AC and BC, the two squares stand on the sides AC and BC. AC is the hypotenuse. So that's the longest side in a right triangle. So we know that all the sides are equal, right? So AC is the longest side. So BC is shorter than AC. BC is shorter than AC in the triangle. So the square, so the square on the side BC will be smaller than the square on the side AC. The square will be bigger, this is smaller. The sides will not be equal. The sides of the two squares will not be equal. Because supposing right triangle, no, we know some values. Let's use let's use say 15 15s are 225, 8 is 64. Yeah, 289, 17. Okay, so let's say this is 8, this is 15, and this is 17. Okay, this is a Pythagorean triplet. 8, 15, 17 form a Pythagorean triplet. 8, 15, and 17 form a Pythagorean triplet. Let's say AB is 8 centimeters, BC is 15 centimeters, and the hypotenuse AC is 17 centimeters. So what about the sides AG, GF, and FC? What are the measures of AG, GF, and FC? How many? 17. Because it's a square. All the sides are equal, 17. What about the sides of BCDE? What will be their measures?
15.
15. Now it's very clear, no, that the two squares will not have the same side. Yes or no?
Yes, ma'am. Yes, ma'am.
Very good. Very good. All right. Okay. So now with this information, we'll have to show that AD is equal to FP. AD is equal to FP. So, you know, I showed you this. AD is equal to FP. Now, AD is, now we'll have to just take two triangles which have these two sides. It's very simple. The proof is very simple. See, that's all. This is the proof. Of course, children, when it is, in this chapter, congruent triangles, you should always write this heading given and write out what is given. Whatever is given here, you should just write that in short. Whatever is given in the question or whatever information is given, you must write that. And then to prove AD is equal to BF. Then if you have any construction, you'll have to write that and then the proof. So you should not write the proof straight away. Given, to prove that, construction if any, and then the proof. All right. So yeah, I'm telling you the proof directly because you know what to write here and here. So I'm not reading this for you. I'm telling you the proof directly. So you can see that BF, BF is a side of the triangle BCF. See here, BCF. And AD is a side of the triangle ACD. ACD, this one. ACD, can you see ACD, ACD, this one, ACD. ACD. And then BCF, 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 because BCF has BF, ACD has AD. ACD has AD, AD. ACD has AD. BCF has BF. So when you take up these two triangles and show that they are congruent, CPCT, you can, get AD is equal to BF. Now, how do you show that, these two triangles are congruent? See here, everything is available. So first here, AC is a side of the triangle ACD. See here, ACD, ACD and what is that? ACD and BCF. BCF. Now see here, AC of triangle ACD. AC of triangle ACD is equal to AC, no? So see the CF. CF of triangle, which is other triangle BCF. Because both are the sides of the same square. Why they're equal? AC is of the triangle ACD. CF is of the triangle BCF. But why are they equal? Because AC and CF, no, they're the sides of the same square. They're two sides of the same square. So they're equal. I'll wait for you to understand. And I'll go to the next one. Triangle selection is, you should take one triangle which has AD and another triangle which has BF. That is how you select the triangles. After triangle selection, you will have to write out three equalities that suit any congruence criterion. AC of the first triangle is equal to CF of the second triangle because they're the sides of the same square. Now, another side of the same square, BC, or you should say CD of the first triangle. CD of the first triangle is equal to BC of the second triangle. BC of the second triangle. See here. BC is of the first triangle. BC is of the, CD is of the first triangle. ACD. ACD. ACD is the first triangle. So CD of the first triangle. BCF is the second triangle. BCF is the second triangle. BCF is the second triangle. So BC of the second triangle. CD, BC. Because again, they are the sides of the same square. Now, the third information is, if you see here, I've marked the angles 1, 2, and 3. Angle 1 is equal to angle 2, 90 degrees. Because square, no, every corner is a right angle. Add angle 3 to both the sides. Angle 1 is equal to angle 2 is equal to 90 degrees. is equal to 90 degrees. Add angle 3 to both the sides. To this one, add angle 3 to both the sides. So you will get angle 1 plus 3 is equal to angle 2 plus 3. Now what is the angle 1 plus 3? What is the angle 1 plus 3? 1 plus 3, this angle ACD. What is the angle 2 plus 3? 2 plus 3, 2 plus 3 is BCF. Is BCF. Clearly these two angles are, this is an angle of the first triangle. This is an angle of the second triangle. ACD, BCF. This is an angle of the first triangle. See, we have mentioned about AC, CD and the included angle ACD. And the other triangle we've mentioned about 2 plus 3 is BCF. In the other triangle, we have mentioned about BC, CF, and the included angle 2 plus 3. That is BCF, angle BCF. So it's clearly the two sides and the included angle. Two sides and the included angle. By SAS congruence rule, the triangle, the congruent, CPCT, you get AD is equal to FP or BF, whatever. AD is equal to BF or FP. You can write FB because it's given here, no, I'll also change this. You can make this FB, children. It's the same, but you can just make it FB. You can just say FB here, FB. Yeah, go through the proof. Yeah, children, please go through the proof. Done, children?
Yes, ma'am.
Have we written this proof? All of you?
Yes, ma'am.
Okay. All right. Okay, here in the given figure, ABCD is a quadrilateral in which AB is parallel to DC. AB is parallel to DC. ABCD is a quadrilateral in which AB is parallel to DC. So what do you call this quadrilateral? What special name can you give to this quadrilateral ABCD? What special name can you give if AB is parallel to DC?
Ma'am, trapezium.
Trapezium. It's a trapezium. Because what's a trapezium? A trapezium is a quadrilateral in which one pair of opposite sides is equal. Oh, sorry, is parallel. A trapezium is a quadrilateral in which one pair of opposite sides is parallel. Okay. On producing, okay, and P is the midpoint of BC. P is the midpoint of BC. Okay. If P is the midpoint of BC, which are the two equal parts? If P is the midpoint of BC, which are the two equal parts?
BP and CP, ma'am.
BP is equal to PC. BP is equal to PC because P is the midpoint of BC. BC. P is the midpoint of BC. So BP is equal to PC. On producing AP and DC, on producing AP and DC meet at Q. On producing AP when you produce it and DC when you produce it, they meet at Q. See, when you produce AP and DC, see, AP is like when you join this point and this point P, you get AP. When you produce AP and when you produce DC, this is DC. When you produce it, they meet at Q. They meet at Q. Prove that AB is equal to CQ. AB is equal to CQ. And then this one. Even if you read, see, it's difficult, meaning you have to start working. So see your DQ is equal to DC plus AB plus AB. Okay. So we'll just see the information given again. ABCD is a trapezium with AB parallel to CD. P is the midpoint of BC. That means BP is equal to PC. AP is joined and produced. AP is joined and produced. DC is also produced. They meet at the point Q. We need to prove that AB is equal to CQ. We'll do that first. AB is equal to CQ. So for AB, we'll take up the triangle APB. And for CQ, we'll take up the triangle CPQ. These two triangles. We'll take up these two triangles. We'll take up this triangle because it has AB. And we'll take up this triangle because it has CQ. We'll have to show that AB is equal to CQ. So simply say that they're congruent. Once they're congruent, CPCT, you will get the result. So you can see it here. In the two triangles, angle 1 is equal to angle 2 because parallel line, transversal, parallel line. Alternate interior angles are equal. Here, parallel line, transversal, parallel line. Alternate interior angles are equal. Angle 1 and angle 2 are alternate interior. How much they measure, we don't know. We don't need also. They are equal. Angle 1 is equal to angle 2. Alternate interior angles are equal. Parallel line. Parallel line. This is also parallel. See, this is also parallel because it's DC produced. DC is parallel, no? So DC produced only. So this is also parallel. So parallel line, transversal. Parallel line, transversal. DC is coming like this. This angle and this angle or alternate interior angles are equal. Alternate angles are equal. Okay, then BP of this triangle is equal to CP of this triangle because it's given. It's given. P is the midpoint. So BP of this triangle is equal to CP of this triangle because it's given. And then angle 3 is equal to angle 4. Vertically opposite angles are equal. Angle 3 is equal to angle 4. All given to you. See, 1 is equal to 2 alternate interior angles. BP is equal to CP, you know. And then 3 is equal to 4 vertically opposite angles are equal. All this information, the first information here is of this triangle. And all this, the second thing, you know, is of the second triangle. All right. So if you want, you can mention here, which are the parallel lines? AB is parallel to CQ and the transversal is BC. BC is the transversal. BC is the transversal. So alternate interior angles are equal. So you get the two triangles are congruent. ABP is congruent to QCP. ASA rule. Two angles and the included side. Two angles and the included side. So CPCT, you get AB. AB is equal to QC or CQ, CPCT. See, here AB is equal to CQ. AB is equal to QC. AB is equal to QC, CP, CTC. Now we'll have to show that DQ is equal to DC plus AB. Now what is DQ actually? What is DQ? DQ is equal to DC plus CQ. DQ is actually DC plus CQ. But we proved that CQ is equal to AB. So instead of CQ, you can write AB. So that's equal to DC plus AB. That's all. See, what is DQ? Actually, what is DQ? DQ is actually DC plus CQ. DQ is actually DC plus CQ. But we proved that CQ is equal to AB. So you can write DQ is equal to DC plus, instead of CQ, you can write AB. That's all. That's the second one. That's the second one. Yes, children. Go through and ask me if you have any questions. Finish writing the third one, children. The proof.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Very good. Okay. Now you can also prove it using AAS. AAS. See, now these are also alternate angles. So see here, parallel line, one. Yeah, these are also parallel line. These are also alternate interior angles. Parallel line, transversal, parallel line. So this angle is equal to this angle. Alternate interior angles are equal. Supposing you mention this. Supposing you mention this angle is equal to this angle. Alternate interior angles are equal. Okay, see it, parallel line, transversal, parallel line, like this, the Z, parallel line, transversal, parallel line. Alternate interior angles are equal. So if you mention that, and vertically opposite angles are equal, and then BP is equal to CP, that will not make ASA, that will make AAS. You can also do it like that. Correct? Yeah. Yeah, Raja, tell me the equalities to prove using the AAS rule. Sindhu.
I'm using AAS, ma'am.
Sorry? Using AAS. AAS. Yeah.
Angle A is equal to angle Q, ma'am.
Correct. Okay, let me number it. 5 and 6. Angle?
Angle 5 is equal to angle 6.
Okay.
Angle 1 is equal to angle 2.
Or you can write, instead of 1 is equal to 2, you can also write 3 is equal to 4. Both will give you AAS.
Yes, ma'am.
You can also write 5 is equal to 6, 3 is equal to 4. That also will be AAS. Yeah, tell me. So 5 is equal to 6, and then you said 1 is equal to 2, correct? Then?
And BP is equal to CP, ma'am.
EP is equal to CP. So by what rule?
AAS, ma'am.
AAS rule, the two triangles are congruent to each other. So once they're congruent, their corresponding parts are equal. So that way you will get, AB is equal to QC. AB is equal to QC. And then to prove this result, actually dq is dc plus cq. But we just proved that CQ is equal to AB. We just proved that it's equal to AB. So instead of CQ, you write AB. So DC plus AB. That's what is the second result. All right, children?
Yes, ma'am.
Yes, ma'am.
All right. Yeah, please write down the proof. As you write, please write, understand the information given. And one of you will explain this proof to me. You can volunteer. See, I called out to Raja. I don't know if he's there or he's not there. Whoever wants to explain, please explain. When you write, try to understand and then volunteer to explain. Done, children?
2 minutes, ma'am.
All right.
Doing, ma'am.
All right, children.
Completed, ma'am. Completed, ma'am.
Yeah. Yeah, I heard you people said you finished. Yes, children, who wants to explain this?
Shall I?
Yeah. Yes, Krishmika.
It's given that OA is equal to OB, ma'am, and OP is equal to OQ.
Okay.
We have to prove that PX is equal to QX
Okay.
and AX is equal to BX, ma'am.
All right.
So yeah, in triangle OAQ and OBP, OQ is
Okay.
equal to P, ma'am. That is given, ma'am.
OQ is the side of which triangle?
OQA.
OQA. Yeah. 1 minute, Krishmika. Before you, say, I just want to share something. Children, now we have to prove that PX is equal to QX and AX is equal to BX. PX and QX. So where is PX here? This is PX. This is PX. And where is QX? This is QX. Okay, let me take a different color. Mm, mm. Okay, this is QX. This is QX. And then AX, BX. Where is AX? AX, this is AX, and BX, this is BX. Oh, not this color, sorry. Oh, yeah, yeah, children. Okay, so we have to see the prove that PX. Can you see the red line segment PX and the yellow line segment QX? The red line segment AX and the yellow line segment BX. So clearly, we have to take up to prove that these two, to prove these two equalities, we'll have to clearly take up triangle XPA. See here, XPA. You'll have to complete it. See XPA. So you'll have to take up triangle XPA and triangle BXQ. BXQ. All right. So we have to take up these two triangles. We'll have to take up Krishmika because I was on the call. See, meaning we just spent missed some time there. I'll just finish it off for this class because it's time. Next class, I'll give you an opportunity to explain something. All right?
It's okay, ma'am.
Yeah. Thank you. Yeah. Yeah, children. Now, do you understand the triangle selection? Do we understand the triangle selection, children? We'll have to prove. Okay. We'll have to prove that Px is equal to Qx and Ax is equal to Bx. Clearly, these line segments are in triangles APX and BQX. These two triangles. These two triangles. So we have to take up these two triangles. But when we take up these two triangles, now let's start from there. See, how do we know that we have to do this? How do we know that we have to do this? Let's start from here only. So we'll take up these two triangles. What will we write? Angle 2 of the first triangle is equal to angle 1 of the second triangle because vertically opposite angles are equal. Angle 2 of the first triangle is equal to angle 1 of the second triangle because vertically opposite angles are equal. And then what else do we know? We know that, see here, it's given that OA, children. See here, OA is equal to OB. Okay, and then OP is equal to OQ. OP is equal to OQ. Now subtract these two results. OA, see, you're given that OA is equal to OB and OP is equal to OQ. Just subtract these two results. What is OA? See here, OA minus OP, minus, take out this, minus OP. It's equal to AP. And what is OB minus OQ? Which is OB? This is OB. This is OB minus OQ minus this one. Take out this. Take out this. All right, take out this one. So what will you get? BQ is equal to BQ. All right. So that's what is this. AP is equal to BQ. Now look for some other information. You will see that you have no other information. Apart from these two, you have no other information. Now see, X is not the midpoint. Now you cannot assume that x is the midpoint and write, xp is equal to bx. Nothing else is given. So you check it out for yourself. Nothing else. We know nothing else in this triangle. No other equality we know in these two triangles, except for vertically opposite angles are equal. Except for vertically opposite angles are equal, and on subtracting these two equations, we get AP of the first triangle is equal to BQ of the second triangle. Other than this, we do not have any other information. In order to get, see, we have two equalities. So we're looking for one more equality. We don't have. So you, after we finish the class, you sit and check in these two triangles if we have any other equal angles or sides. Nothing else we have. So we have to take up some other two triangles, show that they are congruent, and get an equality from that which can be used here. Since we don't have this information, we don't have angle A is equal to B. Angle A is equal to angle B, we don't have. So from the congruency of these two triangles, we prove that these two triangles are congruent, and we get this information: angle A is equal to angle B. Angle A is equal to angle B. We use that here and complete the proof. So like that, we prove that these two triangles are congruent. Once you prove that they are congruent, these two results follow by CPCT. These two results follow by CPCT. So we take up the triangles OAQ. See here, this triangle OAQ, and this triangle OBP, these two triangles. We take up this triangle. See this triangle, this big triangle, and this big triangle, We take up these two triangles. Okay, in these two triangles, so OAQ, in these two triangles, here OAQ and OBP, in these two triangles. OQ of the first triangle is equal to OP of the second triangle. See here, OQ, OP. OQ of the first triangle is equal to OP of the second triangle. Given. And then in the two triangles, you can see a common angle. This angle is common to both the triangles. See here, this angle, because you can see it in this triangle. See, you can see in this triangle, you have this angle. And in this triangle also, you have the same angle. The same angle you have in this triangle also. So this is the common angle, AOQ. AOQ, in the first triangle, it is called AOQ. In the second triangle, it's called BOP. In the first triangle, the triangle is called AOQ. In the second triangle, it's called BOP or POB, common angle. All right. And then we have another thing given here. OA is equal to OB. OA of the first triangle. OA of the first triangle is equal to OB of the second triangle. It's given. See here. OA is equal to OB is given. So we are given that these two sides are equal. We are given that OP is equal to OQ. OP is equal to OQ. Then we are given that OA is equal to OB. OA, this full side, OA is equal to this full side, OB, and this is the common angle. This is the common angle. So by SAS congruence criterion, these two triangles are congruent. So CPCT, you will get this angle is equal to this angle. These two angles are equal. And that will be helpful for completing the proof in these two triangles. So angle A is equal to angle B. Proved. It's proved here. Angle A is equal to angle B, CPCT, it's proved here. So these two triangles are congruent by the AAS rule. You can check it. It's two angles and some other side. We have mentioned about this angle and this angle and some other side. We got, when we subtracted, we got BQ here and we got AP here. Some other side. Angle 2, angle A, and not the included side AX. It's some other side AP. This angle, angle B, and some other side BQ, not the included side BX. So the two triangles are congruent by AAS rule. CPCT, you have these two results. So as I told you, to prove these two results, we have to take up this small triangle and this small triangle. And we'll take up those two triangles. See, how do you know that we have to do this? So actually, we would have taken up these two triangles and started working. So you would have written this vertically opposite angles, and then you would have subtracted this one and got this information, AP is equal to BQ. Then the third equality is not there. So that means you have to take up some other two triangles. So you will strike out what you did. and then you will start again. So you'll start again. So you'll take up some of the two triangles wherein you can use all the information given. You can use this information. So you'll take up two triangles, show that they are congruent, and from their congruency, you will get an information on or an equality, which can be used to prove these two triangles are congruent. So that is A is equal to B. A is equal to B. Use it here and complete the proof. And the result follows. These two results follow by CPCT. Is it okay, children? Understood?
Yes, ma'am.
All right, children. Just there. Raja, are you there?
Yes, ma'am.
I called out sometime once or twice earlier. You did not respond. All right, children, take a screenshot. Complete these by the next class so that you don't have to write during the class. Take a picture.
Taken, ma'am.
All of you.
Yes, ma'am.
Yeah. This one.
Yes, ma'am.
And this one. That's all. Just these three you write.
Yes, ma'am. Yes, ma'am.
All right. I'll not give you too much of work. You might have your school work also. Just please finish all this by the next class. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, children.
Thank you, ma'am.
Thank you.